gentlemen, this is Abhimanyu Acharya from Jadavpur University, Kolkata. First of all, I would like to thank you all for coming over here and allowing us to send you that video presentation. I am here presenting how to generate the arbitrary waveform using a MAME resistive array which is arranged in a crossbar form. This is the whole overview of the presentation which I am discussing over here, or which I will show over here. First of all, it is the basic algorithm for generation of waveform. The basic algorithm implies that with the help of what we need or the requirement of the end user, what he or she desire, here that waveform generation logic is implemented using MAME resistive crossbar array. MAME resistor is actually invented by Leon O. Chua, a missing nonlinear passive two-terminal electrical component relating electric charge and magnetic flux linkage. MAME resistor is the oldest known circuit element with its effect predicting the resistor, capacitor and also of the inductor. The basic algorithm, which is in the next slide, the basic algorithm for generation of waveform, first of all it must be linearly interpolated. By linearly interpolation, it implies towards linearity, which has been proposed by waveform. By linear interpolation simply means if we are required to plot voltage versus time, that is, if I require to plot V versus T as change in time, change in voltage will be some scalar multiplication of the change in time. Then, by on-off theory, this implies towards the fact that for a given cycle, signal or wave is in high state or of off state, depends on the transition or depends on the switching between the states. Then the repeating nature of the waveform, as if we are saying waveform, the waveform must have some form which is repeating. Then the waveforms which have been implemented over here by the proposed method, that is of the form of like some programmable analog circuit. Programmable analog circuit means that method I have used just for the sake of to increase the efficiency of the system and to reduce the time delay. Then here the generation of waveform we have used, the logic is like wire type system and that continuity is maintained. The system response becomes fast in comparison to other. Fast response is said so because the entire process is purely hardware driven with independent of clock pulses or also of the time delay. While we have used here also that as I am previously said that using previous or missing circuit element MAME resistor. Now the method by which these crossbar arrays are used over here is like MAME resistive crossbar array. Here a switching medium is being designed between two horizontal and vertical aligned electrodes as shown. The crossbar arrays are in the form of horizontal and vertical electrodes. There is a bipolar switching between them. That switching medium depends on the resistance with its change in signal polarity. Whenever there is an on state, it implies a low resistance state, and whenever there is an off state, it implies a high resistance state. As shown here, the crossbar with horizontal and vertical electrodes, a MAME resistive material is placed in between them. That MAME resistive material implies the change in the state of the resistance, which implies change of state of the output signal and its polarity. Now, the architecture which we have proposed over here is very simple and logical. As we have learned also in our primary classes how to plot some Y versus X. Similarly, we have also implemented that logic over in the hardware form. To plot V in versus V out, we have used some basic fundamental things. Encoding the output curve from graphical view to horizontal V in and vertical V out electrodes. It is just as like single input and multi output system. The system has high resolution and also more number of and if we want more accurate curve or more accurate readings, more number of electrodes are required. Here by plotting V in and V out, this implies that for a given V in, I am plotting just V out. As for sake of the clarity, we have learned in our primary classes to plot any point, I used to choose on horizontal axis a value of X and then corresponding Y on that value of X, I used to have to choose that corresponding value of Y. Similarly, I am choosing over here for corresponding V in value, I am just plugging or I am just encoding to that value of V out. Now, let's assume that the total input voltage is of span of V volt with n discrete levels. By the mean of n discrete levels, I am saying that there are n number of output lines we can assume. For a given input voltage, corresponding output line is pulled high at first by the desired end user. Now, One more thing I have to mention, that for the switching of the, or for the change of transition from one state to another state, we have used here FET transistor, which has been shown in the next slide. Now, that as if I have used a FET transistor means it will draw some constant current across the load current, and to draw the constant current or to measure that constant current across the load, current mirror circuit is used. As shown in here in the diagram, at first the FET transistor is used for the drawn of constant current source, and to let that constant current to be drawn over here, one by one vertical, one by one horizontal and vertical electrodes are switched on. For a given V in, corresponding V out is switched on, and that corresponding V out is switched on, that corresponding current is measured with the help of the current mirror circuit, which is shown in the rightmost of the slide. Now, once the signal is available in any particular line or wire, it must be proportional to its respective weight as in voltage or current. Therefore, after activation of corresponding lines via input FET transistor, we would draw some certain amount of current and divide it accordingly as presence of number of pull-up resistance, as like voltage divider. This reflected current across resistance must be proportional to the corresponding output line which is active. Therefore, based on these methods, a triangular waveform is generated by programming those crossbar arrays with the help of some binary voltages. Now, programming of the architecture, as I have implied also, the programming of that analog circuit, it is merely coincident with this. Say some input binary voltage is applied on horizontal electrode, as shown here. By the application of the different inputs, I am getting on the different vertical and horizontal electrodes different points at the intersecting point. It means for a given V in, I am getting corresponding V out, which has been shown as dot. Triangular wave is realized by replacing appropriate binary words on horizontal words. Now, the period I have assumed, as we have assumed for the sake of clarity, as 8t, and the pattern which recognizes in the graph is as, say when W is like 0, 0, 1, 1, 1, 1, 1, 1, 0 for a given interval, say 0 to T1, then again for T1 to T2, the line which is switched off, that particular bit is in the low state. As I have previously mentioned, on state means in the low resistance state, off state means in the high resistance state. So the line which will be switched off, that will be of the low resistance state, and that corresponding, and if it is in the low resistance state, the current will automatically drawn from it, and the current mirror circuit can measure the current, and that corresponding voltage can be seen. Which this type of logic is been implemented, or we have implemented here. Now, the pattern or wave which we have generated is simply a right shift of the given pattern of the 0. As we can see that for a given pattern, say assume 0, 1, 1, 1, 1, 1 or 6 or 1, 2, 3, 4, 5, 6, 7 times 1. If we shift 1 by 1, 0, then we will get the required wave, which is shown previously, triangular wave. Then programming the crossbar is according to the user, and now as if say instead of triangular waveform we want some ramp. So by simply programming the corresponding waves or corresponding bars, we can get the required output. Now the entire process is hardware controlled, and it can also work at very high frequency range, because there is no such frequency dependent elements are used over here, so that we can use very high frequency range, so that we can also get output at also very high frequency range. For large precision requirement, very large number of crossbar array is required, because to get an accurate curve, if the crossbar are not in large number, so we are not being able to predict what can be the exact nature of the waveform. So our first task is to, the first task of the end user, that if he or she wants to get the exact waveform, he must use a large number of those arrays or large number of those electrodes. Now its future scope and advantages are: advantage of this method is one of the programming of the array is totally independent of the clock pulse. There is no such DSP component is used. Secondly, the scale at which technology is implemented, and considering the large scale production, it is fairly practical, keeping in mind performance and simplicity of the design and high performance of the circuit. As the design is very simple, it is dependent on the basic logic of the primary classes. Any type of waveform can be implemented using this logic, and further improvement of this design using nanowires, it will obviously give to the high precision arbitrary wave. And these are the references which we have considered. Actually this total work is been proposed using one patent which is invented by Leon Ochua and Hewlett Packard. Thank you.